Alright, we're still working our way through 4.2. Last video I kind of started talking about left and right hand sums and approximating the area under a curve using rectangles that have a height on the left hand point or a height on the right hand point. And I kind of vaguely went over how we actually calculate the left and the right endpoints, but this video is going to be more detailed on exactly how do we find the left endpoints and the right endpoints. So if we take a look here, to calculate the endpoints, we need to do a few things. The first thing we always have to do is find delta x. Delta x is given as b minus a over n, where a and b are your left and right points on the interval. So if we're going from 0 to 2, a would be 0, b would be 2. N, that's the number of rectangles that we're going to take. So in the previous example, we went from 0 to 2 and we did 5 rectangles. So that's where the 2/5 came from. So always find delta x first. And then if you notice, I have the left endpoint and the right endpoint broken down on here. We're going to call the left endpoints little mi and the right endpoints capital Mi. That way we know what we're working with here. Okay, the formula for the endpoints is relatively the same, okay, minus the one little caveat with the I. So if we look at the left endpoints, we're going to go 0 plus I minus 1 times 2 over n. Let me explain a couple things there. I'm using the interval 0 to 2 here to explain this. But where that 0 is, that's where your a value actually is. So it should be like mi equals a plus everything else. Okay, so if we're doing an interval from 4 to 7, you would have a 4 right there. And we're going to do an example later on that actually doesn't start at 0, that starts somewhere else. We can see where that comes into play. Alright, the I minus 1, that's going to stick. That's part of the formula so that we can adjust down. Now, the other piece there is delta x. That 2 over n is really just our delta x, okay? The length of the interval divided by the number of rectangles. So we can just really call that delta x. So if we sum the left endpoints on the right hand side of the page there, I have a lowercase s of n. That's for the left endpoints. We're going to go I equals 1 to n of f of little mi times delta x. Remember, the f of little mi, that's the height of our rectangles, and the delta x is the width of the rectangles. And that'll cover everything for the curve. Then, if we go to the bottom here of the video, alright, the right endpoints, capital Mi. Once again, I'm going to use the interval from 0 to 2 as an example here. So that's why we have 0 plus I times 2 over n, so that's our length of our interval divided by number of rectangles. It's really just I times delta x. Okay, now if we were to start and go on an interval from 2 to 4, okay, then we would still have 2 over n times I, but instead of 0 we would have 2. So there's a shift, and we got to keep track of that so that we align with the interval. But those are the two formulas or equations that you're going to use to calculate the heights of the rectangles. So if on the homework or the test I ask you to do the left endpoint method, you're going to use the top one. If I ask you to do the right endpoint method, you're going to do the bottom one. So your homework problems have you do them with 12 rectangles and things like that. But it is specific. So if you are asked on the homework, say you really only like doing the right endpoints because they're a little bit easier, you will get the wrong answer because the left endpoint method does not equal the right endpoint method. Remember, one's an over approximation, the other one's an under approximation. So make sure you're choosing the right one there. Now hopefully you understand where we develop the endpoints from. So in the next video we'll do an example, kind of like the first one that I guided you through, but now hopefully you have enough background knowledge, understand that we're using rectangles, and now that we can understand how to calculate the left and right endpoints and the width of the rectangle, the next problem should make more sense as we go through it.